Whether my screen is visible. So we have been discussing about. Am I audible clearly?
Yes, sir.
Yes, sir.
Okay. Okay. I will go a little bit fast, and then if you have any problem, you can ask. Okay. Please don't hesitate. So here we have discussed about combinational circuit, and we have discussed about sequential circuit. Most of the combinational circuit we have discussed. An example of those combinational circuit are either full adder, half subtractor, multiplexer, demultiplexer, encoder, decoder, many things. And then we have not even started sequential circuit. So that's why our exam is coming near, and then sequential circuit is very important. So combination circuit is also important, but it is very easy compared to sequential circuit. Sequential circuit will be a little bit difficult to design. Combination circuits, as I have told earlier, they depend on the present input. They don't depend on the previous output. That is the main difference. So you can see over here, you can see many more things, but the main thing is that, well, what I said is combination circuit, their output depends on the present input. Sequential circuit, their output depends on the present input as well as the previous output. So previous output, when I say previous output, so sequential circuit should have memory elements, whereas combination circuit is the output depends on the present input. There is no question about the previous output. So memory is not required. Memory is not required. So these things you can read, you can find it at anywhere. So the main thing is that sequential circuit output depends on the present as well as previous output. That is the main difference. And sequential circuit are complementary, harder to design. All these things are not required. Sequential circuit are slower than combination circuit. What is the meaning of this? Sequential circuit are slower than the combination circuit. I cannot understand. Then the meaning is that sequential circuit, they are slower. Why? Because we need a clock. And then the output also depends on the present input as well as the previous output. So it will be slow, but the combination circuit will be fast because as soon as you give input, you will have the output. Output depends on the present input. So combination circuit are fast in speed because the delay between input and output is due to propagation delay of the gate only. Propagation delay of the gate. Propagation delay of the gate means what? We are not discussing much on this. Propagation delay means the name itself suggests propagation delay. Suppose in a NOT gate, you are giving 0, output will be 1. So as soon as you give 0, output will be 1 suddenly. No, there will be little delay that we never consider. We never talk about it. So that is called propagation delay of the gate. Every gate will have a propagation delay because gate is also made up of transistors inside. So there will be delay. That is what they are telling. So sequential circuit will be slow because for a sequential circuit, they will wait for a clock. In most of the sequential circuit, you will have a clock. And also in the sequential circuit, you have a memory element. So the output depends on the present input as well as the previous output. So sequential circuit will be slow compared to your combination circuit. So flip-flop is one example of sequential circuit. And flip-flop, why is the name called flip-flop? It can flip from one state, it can flip from another state. What do you mean by one state to another state? Because flip-flop can have 0 or flip-flop can have 1. That means flip-flop can be used as a storage device, memory element. Okay, so what it can store? One flip-flop can store either 1 or either 0. That means every flip-flop, how many flip-flops are there? There are 4 numbers of flip-flop. SR flip-flop, ZK flip-flop, D flip-flop, T flip-flop, that we'll come to know, all those 4 flip-flops. So all the flip-flops can store either 1 or 0. That means it is a single bit storage. It can store single bit. A single bit can be either 0 or single bit can be either 1. So single bit means only 1 bit it can store. So that bit can be either 1 or 0. So it is also the basic, okay, sequential circuit. This flip-flop. The simplest kind of sequential circuit is a memory cell that has only 2 states. Why they are having 2 states? Because it can either have 0 or it can either store 1. That's why it is called 2-step. So it is the flip-flops. Okay. So flip-flops can be also called as bistable multivibrator. EC people might be knowing what is a bistable multivibrator. We'll come to know. It can be called as a latch or it can be called as a toggle. So there are different names. But strictly speaking, the name itself has a different meaning. There is difference between flip-flop and latch, strictly speaking. So in most of the exam, they will ask, what is the difference between latch and flip-flop? That also will come to know. So we are just trying to know that there is something called flip-flops, and it can have, it can store one single bit, and it can store either 1 or either 0. That is why it is having 2 states. It is having 2 states. That is why it is also called as bistable, 2 stable states. Bi means 2 stable states. So bistable multivibrator, sometimes latch. We'll come to know all these things. So now let's say what is a bistable multivibrator. This is a bistable multivibrator diagram. I will go quickly into this. So electrical students, they have already understood this one in the lab. So this is suppose set. Set means what? Set means 1. We call it set. We have something called set, and we have reset. Set means it is stuck to 1. Reset means it is 0. Okay, reset means we consider is 0. Set means 1. We normally consider set means it is set to 1. Reset means output is 0. We normally think like that. So let us think that this is 1. This is 1 means plus 5 volt, or this is high. If this is high, this is high. This is high. If this is high, this is P type, this is N type. So this is nothing but NPN transistor. PN, why I say, because this indicates the forward bias. Emitter to base should be forward bias. That means if it has to be forward bias, this should be P type, this should be N type. And this P is connected to high. That means this is now in the forward bias. Okay, very good. Then this will conduct, and then this will be on. If this is on, it is something like a resistor connected over here and a switch over here. This switch is closed, and there is ground. This is plus 5 volt. This is given, and this switch is closed. Earlier it was open, now it is on. The switch is closed. The switch is closed. The switch is closed. If the switch is closed, the voltage at this point will be ground. It will be ground voltage, 0 volt, or near about to 0 voltage over here. Because this nothing, this is a wire. Voltage at ground and voltage over here, it should be same, because there is no resistor over here. Strictly speaking, there will be a little bit of resistance drop because of the connecting wire, so that will be neglected. So around 0 volt I can say, or low I can say. So the voltage over here will be low, and as you see, the voltage is low, and this voltage is connected over here. That means over the Q2. Here, this is also direction says this should be positive, this should be negative. So this is nothing but NPN transistor. Why I say NPN transistor? Because this arrows indicates that this is the current direction. So this is an emitter to base connection. So emitter to base will be always forward bias. Emitter to base will be always forward bias, and arrow indicates the direction of the current. That means current goes from positive to negative. So in order to make forward bias, this should be positive connected, and this should be negative. But as this is low, and this low is coming over here, and this is low here, it should be high, then only it will conduct. It will not conduct. This will be not in the forward bias. This forward bias will not be able to achieve because the base is at low potential. So this Q2 will be off. This Q2 is off. If this Q2 is off, suppose when you have a switch, same like this, one resistor is there, and this is off, this is open, and you have resistor over here. This is open, the switch is open. This is a switch, it is now open. This is not closed, this is open. If the switch is open, then what will the voltage over here? The voltage over here is 5 volt. The same 5 volt will be appeared here. 5 volt, it is open. You have a battery. You just measure the potential difference. This is plus, this is minus. 1.5 will be there. No wire is connected, just you are measuring open. So if it is open, if the circuit is open, even though there is resistance, no current will flow, there will no drop. So exactly 5 volt will appear in the open terminal. That means since this is off, this 5 volt, for example, high, I call it high voltage will appear. So this high is coming here, and already it was high also I have given, but now it is high automatically. So now it is high automatically. That means what? Even if I remove this, even if I now disconnect, even if I disconnect this will become high. And if this is high, this will be on. If it is on, this Q bar voltage at this point, then this Q bar will be low, that is 0. And this is high, then Q will be equal to 1. Q will be equal to 1, so we can conclude that Q will be equal to 1 and Q bar will be equal to 0. It will be like this forever. That means this particular device is going to store 1. Q is equal to 1. Output is equal to 1. It will be always stuck to like this. This will be always high. This will be always high. Even if you remove the input also, this will always high. So it behaves like a storage. It stores 1. So we have 2 outputs, so only 1 output is considered because Q and Q, another one should be complement of it. 1 is Q, another is Q bar. So if Q is 1, then obviously Q bar will be 0. So we considered only 1. So now it is 1. I can say that this particular bistable multivibrator, it is storing 1, 1. Now it is having 2 states. It is having 1. 1 is 1 state. It is 1. If you want to change it, if you want the device to store 0 instead of 1, then instead of this set, in this set, you have to give low voltage. You have to make this low. And here you have to give high voltage. And reverse thing will take place. And reverse thing will take place. Now Q will become 0. And Q bar, obviously, it will become opposite. So 1. It will become like this. And it will be like this unless and until you give another input signal. Okay, that is why it will stuck to these particular values unless and until you give another input signal. So this is why we call it a bistable multivibrator. Based on the input you are giving set. When the set is 1, the output is 1. Q is equal to 1. This is 1 state. When the set is 0, then Q will become 0. It is another state. High state, low state. So it can store either 1 or it can store either 0. It can be in the high state, it can be in the low state. That is why bistable multivibrator. So the bistable multivibrator works like that. So any problem? So if you don't ask any questions, I will continue. Whether you understand or not, that is another thing. If you don't ask or if you don't respond, then I don't have time to ask you frequently because I have to continue. So am I audible?
Yes, sir.
Yes, sir.
You don't have any problem? Okay, we continue. Then this is one flip-flop. This is called flip-flop. They are writing SR flip-flop, but strictly speaking, this flip-flop, I will not call it LLATCH, latch. I will call it latch because there is difference between flip-flop and latch. So some books, they simply give the name interchangeably. They interchange it, latch and flip-flop, without much difference. But there is a wide difference. I can call this as a latch, not a flip-flop, even though the book says, I will not say, because this is a flip-flop. Okay, this is a flip-flop, and this is a NOR gate. This is a NOR gate. So this is NOR-based SR flip-flop. NOR-based means what? It is made up of NOR gate. And how it is going to do, I will tell you. This is the connection, and then see, the output, as I said, sequential circuit output depends on the previous input and the previous output. So this is my output Q. This output for this depends on what? Present input as well as previous output. Can you understand? This is the output is feedback over here. So now the output Q depends on the present input, what is there, and the previous output. Similarly, Q bar also depends on the present input S and the previous output Q. Is it okay? Now, this is NOR based SR flip-flop. If you have any problem, you can ask. NOR based SR flip-flop. And I said let's. I call it let's because it doesn't have a clock. It does not have a clock. Any let's or whatever let's will not have, if it is a latch, it will not have a clock. It will never have a clock. Okay, then it is called a latch. Because whatever the output Q or Q bar, the output will depend on the input, what is at present input. It will not wait for any clock. If I say clock means what? When the clock is right time at 5 p.m. only you turn on. It is not like that. There is no clock. So even if the input is there, if there is clock, even if there is input, if there is clock, then I have to wait for the clock. If the clock is right, then I have to give the output. So let's is something where we don't have a clock. That means as soon as you receive the input, you will get the output, because the previous output also, you know it, and so it is connected. The previous output are connected and fed it to the input. So the output depends on the present input at that time as well as the previous output. So as soon as you give the input, you will get the output. That is flat. That means in another sense, it is event trigger. Event will trigger. Event means what? Sometimes R and S. What is R? What is S? R is reset pin input. S is a set pin. They just give the name R and S. That's why it is called RS flip-flop or RS latch. So R can be sometimes 0. S can be again 0. R can be 1, 0, 0, 1, 1, 1. Any conditions can be there. So this is one event. When R is 0, S is also 0, this is one event. When R is 1, S is 0, this is another event. When R is 0, S is 1, another event. When R is also 1, S is also 1, this is another event. So for a latch, it is event trigger. Be thorough with this. It will be event trigger. As soon as you receive the event, the circuit will get triggered and you will receive the output. And this is the same SR latch. I will also call it as latch because we don't have any clock. This is SR latch. And if you have been asked to construct SR latch using NAND gate, then you have to draw like this. And what is the difference? Because these are from two different books. That's why sometimes Q, sometimes Q n plus 1. Don't worry about these things. I will come to know. You come to know this terminology. Don't worry. Sometimes Q n plus 1. Why is it? I will tell you. Okay. So this is NAND base. So in NAND base and then in the NOR base, you just see in the NOR base, Q is here, R is here. Don't change this thing. This is I was making mistake when I was a student because I don't understand all these things. So don't repeat just such type of mistake. So this is set and this is Q, and this is not set. This is set bar, set and then bar. This is opposite of set. Okay, be careful while drawing. You cannot put R and you cannot put Q here if it is NAND base. If it is NAND base, S bar and then Q. Okay, and then you observe carefully Q and Q bar. That means Q, another output is Q bar. What does it mean? Q and Q bar means when it is 0, it should be 1. When it is 1, it should be 0. They cannot be, Q cannot be equal to Q bar. How? Q, how can it be equal to Q bar? 1 is the complement of other. That means if it is 0, it should be 1. If it is 1, it should be 0. 0, 0, 1, 1, invalid. Both the output cannot be same. That's why the output is named as Q, another one is same thing but bar. That means the two outputs are complement to each other. They are complement of each other. That also you should keep in mind. And this is your S bar and R bar. If I want to make it S and R because it looks very inconvenient, then you have to put one more NOT gate. You have to put one more NAND gate. You have to put one more NAND gate, and you know if the NAND gate will become NOT, then you can put S, and here you have to put one NAND gate, and both input you just connect it together, sort it, and we put R. This S will become S bar, R will become R bar. So there is not a big issue when you try to change to SR flip-flop, and SR, I should say latch, SR latch should look like this. It should look like this. Any problem? This is just a construction. Function will do. Any problem? No problem, no question, no answer. Okay. Now, this is the SR. Just now I have drawn. This is your S bar, yes. This is your R bar, yes. This is NAND base, okay. QN plus 1, QN, Q bar, N plus 1, okay. S and R, okay. Okay. And this is with clock. This is without clock. If it is this clock, then I can call it flip flop, no problem. It is having a clock pulse, and it doesn't have a clock, so I can call it as latch, SR latch. Flip flop or latch, the operation is same. The operation is same. The operation is same in the sense that their truth table is same. Okay, are you thorough with the diagram? There is any confusion with the diagram? No confusion. No. Clock means whenever there is a clock. Suppose, see, what they are doing, they are just joining one of the input together. See, one of the input together, clock. So when clock is 1, only when 1, see, in NAND gate, when one of the input is 1, the output is what? A bar. You will come to know. In NAND gate, when one of the input is 1, NAND gate. Can you understand? In NAND gate, you just see the truth table of NAND gate, opposite of NAND gate. If one of the input is 1, then the other output. Hello, Jack. Kai di pamila class lori. Tung terkuat. So in NAND gate, what is that? Suppose you have two inputs, A and B, 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 means 1, whatever 0, 1, 1, it is 0. This is NAND gate. So when you have one of the input is 1, see, one of the input is 1, one of the input is 1. The output is nothing but opposite of this 0. Opposite of 0 is 1. When one of the input is 1, the output is opposite of this 1. This is 0. That means when one of the input is 1, the output is opposite of A. That means A bar. So it's very good. So when the clock is high, when the clock is high, then only you will have S bar here. Then only you will have R bar here. That means when the clock is high, when you give clock to be 1, when you give clock 1, then only the circuit will work. When the clock is 0, the output is 0, circuit will not work. Can you understand?
Yes, sir.
Circuit will be 0 means when it is 0, when one of the input is 0, when one of the input is when one of the input is 0, what is 0? It's 0. Output is 1. When one of the input is 0, output is 1. That means here it will be 1, it will be 1. So in 1 cases, the flip-flop does not work. I will tell you why it doesn't work. Can you understand what I'm saying? Or do you have any question?
No question, sir.
So this is again SR-lets. Now we can call it flip-flop because we have a clock. This is your SR. This was my R. This was also my S. This is NOR base. NAND base and NOR base, they are different. So you try to understand only one. Don't mix up. For the sake of your understanding, I'm drawing it. I'm giving you different diagrams, but you stick to only one. You stick to only NAND base flip-flops, because in the following chapters we'll be discussing only with the NAND base. So anyway, this should be R instead of S. It should be R because this is NOR base R. So if I want to introduce one clock, then don't put NAND, is AND gate. If one of the input is 1 for AND gate, whatever output R, I will get R. That is the beauty of AND gate. So all those things you should know. When clock is 1, whatever R, you will be able to get it, because this is not a NAND gate. This is AND gate only. So I know the truth table of AND gate, and I came to know that when one of the input is 1, the output is the other one. R will become R, S will become S. So this is clock. Clock SR flip-flop using NOR. I can call it flip-flop because that is a clock. Okay. Now, what is SR flip-flop going to do? Now, this is a truth table. You should be very careful with this one. Qn plus 1, they are saying. Then another one is Q bar n plus 1. I don't need to focus much on Q bar n plus 1 because Q n plus 1 is enough. If I know this should be opposite of that very well. So I will focus only in this. So what is Qn plus 1 telling? Qn plus 1 is telling that it is my, as I said, for a sequential circuit, the output depends on the present input as well as the previous output. So Qn plus 1, let us call it as a present n plus 1 or next. So I can call it present and past, present and next, past, and because it's up to you, because n plus 1 is the next one. N plus 1 is the next state. Qn is the previous state. Qn is the previous, n plus 1 is the next. Or if you are confused with that, Qn plus 1 is the present, a VAB, present, and Qn is the previous. That also you can think. So by the nomenclature, n plus 1 means 1 stays ahead. N means previous. So previous, present. next state or present state. Do you confuse what I say? So there is no confusion. In whatever manner you want to think, you can think. In some book, they will write Qn. And instead of Qn, they will write Qn minus 1 in some book. So they think Qn as a present, Qn minus 1 is a previous. That also is good. The only thing that there should be difference. So Qn plus 1 in this book, it's a next state, and this is the present state. And next state, what will be the next state? Okay, because the output of the sequential circuit depends on the present as well as the previous. So based on the definition, I will think this is a previous and this is present. That's also possible. So what it is saying, irrespective of flip-flop or latch, whatever, SR flip-flop or SR latch, these two tables holds good, same, true every time. So they are saying when S and R, when both input, whether it is a NAND-based SR flip-flop or NOR-based SR flip-flop or latch or whatever, if S is 0 and R is 0, if S is 0, R is 0, the output is nothing but your previous output. Whatever you're going to output is going to be your previous output. What was my previous output? My previous output was 0. Then now it will also be 0. What was my previous output? Okay, your previous output was 1. And now your output also will be 1. Because S is 0 and R is 0. So your previous output is nothing but, the next output is nothing but your previous output. That means no change. No change means what? Pehle jo hai, abhi bhi hai. What is there in the previous, the next also will be the same. So there is no change. Can you understand the meaning? The output will not change. What was my previous output will be my present output. So the output will not change. When S is 0, R is 0. That means you should remember this. This truth table for all the flip-flops you should remember. Otherwise you cannot design. So any problem, if you have any problem, you can tell at any point of time. So when S is 0, R is 0, it should be, output should not change. There's no change. That means my previous output will be my next output also. So my previous is 0, your present or next will also be 0. My previous is 1, then now also it will be 1. Okay. So now you just see next. When S is 0, R is 1. When R is 1 means reset. R is reset. Reset means what? Output is 0. Fix. If this is 0, this should be 1 because they should be complementary to each other. No problem. If reset is 1, then S is 0, then we call it is a reset. No problem. And when S is 1, then we call it set. S is set. R should be 0. This condition we call it set. And output will be set. Set means 1. Output is set to 1. And obviously this will be 0. When is 1, when this is 1, S is also 1, R is also 1, this is invalid, forbidden. Why forbidden? Because if S is 1, R is 1, you will come to know that output Q is equal to Q bar. How can Q be equal to Q bar? One should be complement to other. If it is Q is 0, it should be 1. If it is 1, it should be 0. They are complement to each other. They should not be equal, but it will become equal if R is also 1, S is also 1. So we call this as a forbidden. That means never apply such type of things because it violates the condition that one should be Q and another should be Q bar. So we should never give these things. Can you understand? So having these things in our mind, we will focus this truth table. This truth table, we will focus here. We will focus here and we'll just see. This is a latch, SR latch. This is having lots of diagram. We'll go to the simple one here. We'll see. You can analyze in any circuit because this circuit is simple. This circuit is simple. It has very less this thing get number of get is very less. Here also it will be simple, but S bar is coming into play, so you'll confuse. S bar is coming into play. You may confuse. We can introduce not get and we can start, but it will be lengthy. But here it will be easy to analyze. So let us analyze the thing. Let us analyze the thing. So so anything for time being, for the sake of simplicity, I will just take one condition. One condition, like for example, so let me take one example, like S and R. S, R flip-flop, 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1. This is my QN, my previous one. This is my QN. And I don't bother about Q bar. This is my QN plus 1 next. Okay, I don't bother about the next one. QN bar, it will be, I will not write because it's wastage of time. And as I know, SR flip-flop, because we have to mug up. We have to mug up in the sense we should know. It is 0, 0, 0, 1, 1, 0, 1, 1. We know that this Q of N plus 1, the next step will be, if 0, 0, there's no change will be, the previous one will appear, QN will be appeared. What is in the previous QN will appear again. If R is 1, this is reset. If this is a set, this is forbidden. It's very simple to remember this. This is a truth table. Okay, if we know this, now I will not waste time for you. For those students who are smart, you can also answer me. Like, let's say this is 0, this is 1. Because QN can be 0, QN can be 1. I'm thinking it. QN can be 0, QN can be 1. This is just a comprise, a very compressive truth table, which has a meaningful, which has a very meaningful kind of thing in a precise way. This is elaborate way. When S is 0, R is 0, what will happen here? Exactly 0 or 1?
0, 1.
What will happen here? What will be here?
0, 1.
What will be here in this row?
0.
0. Why?
Because it must be the previous one.
Yes, the previous is 0, so it will become 0. What about here?
1.
1, exactly, because the previous is 1, so now will be 1. So this is nothing but the previous one. I got it. Whatever previous, I got it. When R is so I'm giving some this one. Let it be 0, let it be 1. I don't bother what this is 0 or 1, because if R is 1, means reset 0, 0. I don't bother over here. If it is R is 1, reset. This says if R is 1, reset. Reset means 0, means output is 0 means reset. This is what this is set. This is reset. This is forbidden. Forbidden. This is no change. We know it. So when it is set, this is set. I don't bother whatever 0, 1. Even if you want to write 0, 1, you write it. But I don't bother. This will be set or will be set. This is reset, reset. This is set. And when the both outputs are 1, 1, 1, 1, I don't bother whether you are 0 or 1. I don't bother. I don't bother. Don't do this. This is forbidden. This way you can get the truth table. That means I am simply telling, I don't apply in the circuit. I simply say, when output is this, the next output will be this, that. I am simply saying. So it is hard to believe, sir. Some students say it is hard to believe. You are simply explaining based on the truth table. You have never applied to the circuit. Please apply to the circuit and let us see how and up to what extent the output is matching with the truth table. So we cannot verify each and every output because of time constraint. But anyway, I will try something. Like for example, let us imagine. So this is R is 0, 0. Okay, 0, 0. No change condition. No change condition. When R is 0, S is 0, output will be no change, right? Can you understand?
Yes, sir.
Yes, sir.
So when S is 0, R is 0. When S and R both are 0, then output will be no change. That means what? I have a previous output 0. Previous output, let's say, previous. Purana, previous output is 0. I have a previous output 1. That is what? My QN previous is 0. My QN bar should be obviously 1. So previously I have QN 0 and 1. I'm just analyzing it. And the theory says, the truth table says there should not be any change. Let's see. 0 is coming here, 0 will come here because it is connected. 1 is going here, it is connected. 1 and 0. 1 and 0 is what? In OR gate, 1 and 0 is 1. 1 and 0 is 1, but there is one bubble. there is one bubble. So in NOR gate, 1 and 0 is output is 0. So the next one I'll put it somewhere far. Another color I can use, it will take time. So this is the next state. 0 is coming. Simultaneously, here also 0 simultaneously, because I cannot talk simultaneously, but this circuit will work simultaneously. The previous 0 is also coming here. 0 and 0, 0 and 0 is what? 0 and 0 is 0, opposite bar, so it will be 1. 1 is coming. So new is 1. New is 1. Now, this 1 is going again. This one, this previous one, this is new one. This new one is again fed here. So it is 1 again. This new one is again fed here. This is also 0 again. Now let us think 1 and 0. 1 and 0 is 1, bubble 0. Another one is also coming 0. The next state is 0 coming. Here also 0 and 0. 0 and 0 is 0, bubble 1. 1 is also coming again. So it keeps on coming 0, 1, 0, 1, 0, 1. It will always stuck to 0 and 1. That means the output never changes. The previous output was 0 and 1, I considered, but it stuck to 0 and 1 always. So output never changes. Can you understand what I'm saying? Can you understand?
Yes, sir.
Yes,
So
sir.
output never changes. So let us think another conditions like set. Okay, let us take one example for set. Set, when I say it will always set, it will always set. It will always set, I'm saying. Let's see whether it is always set or not. So we will just see set होने के लिए set को 1 देना पड़ेगा. I have to give 1 here and it will be 0. Then I said output will set. This Q will become 1 and this will become 0. This is my understanding according to the theory, according to the truth table. It says like that. Now, let us say instead of 1, let me put 0. Previously, it is 0, let's think. Anything you can think. I'm thinking 0. Then you should think this to be 1 because this should be complement. So I take this 1. Previously, it is 0 and 1. 0 will come here. 1 is joined here. Then 0 and 1. 0 and 1 is or 1. 1, 1, bubble this. Then the next step will be 0. Next step I'll keep it over here. Next step is 0. So 0 and previous one was going also here. Simultaneously, this also will work. 0 and 1. 0 and 1 is 1. Bubble 0. So 0 will come over here again. Can you understand? Am I right? 0, previous one will coming here. 0, 0 and 1. It is 1, bubble 0. So 0 will come here. So my new state is 0. My new state is 0. But they are telling that the output should be 1, 0. Don't worry. This is a transition. This is a transition. Transition in the sense, this is 0, this is also 0. Now what happens? This 0 will go here. Now it will become 0 as it is. This 0 will go here. It will become 0 again here. 0. Now 0, 0, 0, bubble 1. Now next it is 1. 1. 1. So here 0 was there. 0, 1, 1. Or get 1 bubble. So 0. 0 is coming. So now it is 1, 0. So is it stuck to 1, 0? Let's see. This 1 is coming again here. This 1 is coming again here. This 1 is coming again here. And it becomes 1. This 0 is going here, going here, going here. It becomes 0 as it is. 0 and 0, 0, bubble 1. So again 1 is coming. 1 and 1 is 1, bubble, the 0 is coming. So 1, 0, 1, 0, 1, 0. Always it will stop. So this 0, 0 is just a transition. This one and this one is just a transition. Don't, it will be a flicker, a few fraction of a second it will be appear like this. But the rest of the time it will be 1 and it will be 0. That means when the output input is set, output will be 1. Q n plus 1 will be 1. Next step will be 1. Good. It's matching. Can you accept it? Can you accept my? Can you understand it? What I'm saying?
Yes, sir. That means the Q bar is not the input now, sir.
Q bar is not input means what? Q bar is the input to over here because they are all feedback. That is why it is called sequential circuit. The output depends, this Q bar output depends on what? This input and the Q output, previous output. And this Q depends on what? Depends on what? These are two inputs, one input, okay, present, and another one, this output is feedback. So it depends on the present input as well as the previous output, present input as well as the previous output, like that. So if from the analysis, when S is 1 and R is 0, you take again anything. Now I was taking what I was taking. I was taking previously 0 and 1. Let me take another one now, because if you don't understand this, you cannot proceed, because you should be very thorough. Then only you'll be able to master it, because questions will not be that easy. Now let us say that this is 1. Let us say that this is 0. Okay, now let it be, this will be 1, this will be 0. This is what? This is my previous output. Previous output. This previous output is connected here. That's why 1 also will be coming here. So yeah, they are all connected in one wire. This 0 is connected over here. So 0 will come over here. 0 and 0 in this is NOR gap. 0 and 0 pehle OR karo. 0 and 0 OR means 0. Bubble. So opposite 1. 1 will come here. 1 will be nexted. I will write here. 1 will be a nexted box. This is Qn plus 1. And this is Qn. Qn was 1. Qn plus 1 is also 1. This is Qn, 0. I was considering it. And what about Qn plus 1? Q bar n plus 1 here? 1 and 1. 1 and 1. 1 and 1 is 1. Bubble. So 0. 0 will come here. So 0 is the next state. So this is 1 and this is 0. Good. They should be complement to each other. So Q is equal to 1. Q bar is equal to 0. Good. It is matching. They should be complement. 1 is complement to other. Q and this bar. That means bar of 1 is 0. 1 bar is 0. Correct. And will it stuck to this this thing always? Let's see. This, if you want, so because I want to go for another state, next state. Next state. I mean, next kya hoga? What will be next? If I want to know the next output again, then this will become the previous output again. This 1 will go, this 1 will go here, it will become 1. This 0 will go and it will become 0 here. Because if I want to go for the next step, means abhi bizo hai, that will be the previous now. So now 0 and 0 is 0, opposite 1, 1 will become the next. This was my previous, now this was my Qn, this is now my Qn plus 1, now like this. Can you understand? This 1 is going here, 1 and 1 is 1, opposite is 0. So now final answer is again 0. So this is my Qn plus 1 bar, and this is my Qn bar. Now this Qn plus 1, if I want to go for another step, next step also I want to say, check, yes, then this 1 will go here, this 1 will go here, 1, and this 0 will go here, 0, and 0, 0, 0, bubble, 1, so 1 will come here. So this 1 will become your Qn plus 1, and this will become your Qn previous. Like that, it will keep on going, because that means what? It is always stuck to 1, and this is always stuck to 0. That means your output for the input, S is 1. When S is 1, this one. When S is 1, you will get the output Qn plus 1, always 1. I am focusing here, always 1. Why should I focus here? If it is 1, it should be 0 by default, because this output is called Q, this output is called Q bar. Then why should I focus on Q bar? Even if you want to focus, you focus. It's a wastage of your time. If I know Q, I should be able to say Q bar. Very simple. So there is no question of knowing what. If I know Q, then Q bar means what? It itself is saying Q bar. Q bar means it's the opposite of Q. Can you understand what I'm saying?
Yes, sir.
Yes, sir.
Now let us see the forbidden condition. Forbidden. Forbidden means what? This is when I was a student. I also want to know what is this forbidden? What is this forbidden? But I cannot blame the teacher. They never teach. They never tell me. They simply see the truth table and then they finish up. But I want to check what is forbidden. What is forbidden means why they are calling forbidden. Forbidden means output will be same or whether hot will be there. So if it is 1, this is 1. So Q and Q previous, and this is my present input 1, 1. This 1, 1 is forbidden, they are telling. So let's see whether it is forbidden or not. So in order to do that, what I feel to know is that mera purana output ka kya hai? What was my previous output? Can you understand? Just tell me anything. Tell me anything. Previous output kya hona chahiye? Just tell me anything.
In Q, you write, sir, 1. And
Okay,
Q,
1 and 0 I'll put. Okay. You can do anything. Okay. You can do anything. You have to hit a trial method. You can try it at home also. So 1. So this 1 is a previous. So this previous will come here. It will be 1. Now this 0 will go here. It will be 0. Now 1. This is 1. This is 0. This is 1. This is 1. 1 and 0. 1. Bubble. So 0. This is my next step. 0. 1 and 1. 1. Bubble. 0. This is my next step. 0. Are they stuck to 0, 0? We'll see. And then this 0, if I want to go for the next state again, what is this? If I want to go for next state, what is this? Then this 0 will go as an input. Now, this 0 will go as an input, so 0 will come here. This 0 will go as input, 0 will go here. Okay. So 1 and 0 is 1. Bubble, 0 will again come here. 0 and 1 is 1. Bubble, 0 will come here. So now forget about this. Forget about this. This is my new one. Then if I want to go for another new one, another new value, if I want to see, then this 0 will go. 0 will come. This 0 will go. 0 will come. So obviously the same thing. 1, 0, 1, opposite is 0. 1, 0, 1, opposite is 0. This is my previous. Now this is my new state. This is my new state. So Q is going to be equal to Q bar. How come? Don't do. Don't do. Don't try. Don't try this. Okay, because the concept that we want to develop is like one should be Q, another should be Q bar. This is the concept that we want to develop. We want to inject to you students or to the engineers. But when I give R is 1, S is 1, it contradicts. There is a confusion. So, okay, let us not use this condition. When R is 1 and S is 1, oh, my circuit is not working properly. Let us hide this thing. Don't say it to anyone. Let us not use this one. Let us not use this one. So they just put it forbidden. So if it is NOR based, as I said, if it is made up of NOR, whether it is flip-flop or whether it is latch, you know what is the difference between flip-flop and latch? Flip-flop, you will have a clock. Latch, you will not have a clock. You will never wait for the clock. Instead, as soon as you get input, you will have to give an output, that is latch. Whereas in case of flip-flop, even though you have an input, you should wait for the clock, whether my clock is on or off, like that. So that is the difference. So if it is NOR based SR flip-flop, when S is equal to 1, just for the sake of understanding, R is equal to 1, you will get Q is equal to 0 and Q bar also will be 0. That you just keep in mind for yourself. If it is NAND based, you can come here. You can come here. If you want to analyze S bar, very difficult S bar, I may confuse. Okay, then put like this. One, as I NAND based, this become S and this become R bar. R. This become S and this become R. Here also you can analyze the same thing. When S is 0, okay. When R is 0, okay. And this is, let's say now 0 and this is 1, okay. Let's see, let's analyze, okay. Same thing will happen. Here you will find Q to be 1, 1, it will stop. So you should remember, if it is, it will not ask in the exam, but for the sake of your understanding, if it is NOR based, the Q will be 0, or the Q will be 0, Q and Q bar will be 0. If it is NAND based, Q and Q bar will be 1, 1. Okay, let's see. 0 is coming, 0 is coming, 0 is here. 1 is going, 1 is going, 1 is here. What is this S? S is 0. What is this S bar? This will be 1. What is this R? Oh, 0 is not 0. It will be 1, 1, no. 1, 1. If it is 0, 0, no change. 1, 1. S is 1, it will be 0 S bar. R is 1, and then it will be 0. So 0 and 1. 0 and 1 is multiplication 1. 0, bubble. So it will become 1. 1 will be my next step. 0 and 0, when you multiply 0, bubble. So 1. 1 will be my next step. So you forget about the previous one. Now this will become previous. If you want to go for another condition, if you want to work on for another condition, this 1 will go here, it will become 1. This 1 will go here, it will become 1. 1 and 0. 0 into something is 0, bubble, so 1 will come. 1 and 0. 0 into 1 is always 0, bubble, 1 will come. So this 1 is again coming. So this is my khatam ho gaya previous. So this is my present output 1. You want to go for another one, another condition you want to check. This 1 will go here, 1, same thing, it will appear 1 will come. So it will always stuck to 1. That means your output will become when S is 1, when R is 1, and if it is NAND based SR flip-flop, your Q is equal to Q bar and is equal to 1. Q bar will be same and it will be equal to 1. Q bar will be same and it will become equal to 0 if it is NOR based SR flip-flop or SR latch. Is it okay?
Sir, excuse me, sir.
Pardon?
Sir, I have doubt in this circuit. So
Which one?
This one in R, no, sir.
कौन सा
Can
वाला?
you explain this? Sir, ये वाला Q and Q dash, Q bar and Q is there, no? So can we interchange that one?
No.
Q, we can write Q bar.
You cannot interchange. Don't interchange. So you by mistake, don't do that. S, wherever there is S, you have to put QN. You have to say QN, this one. QN or Q. If it is S, wherever you are writing S, then you should write this QN or QN plus 1 without bar. And if it is R, then in that place you have to put opposite QN bar. So you may think like what? See, I will tell you your confusion. You may think
Sir,
like
yes, upper side and lower side, they are different, no, sir.
Yes. I understand what you're saying. So what you're saying is that you may feel like one and other both are complement to each other. So why not, if I sometimes by mistake, if I put QN bar here and QN here, will there be a big mistake? Yes, there will be a big mistake. There will be a big mistake. It will be a big mistake. Can you foresee that mistake? Can you see the mistake? Can you think? When I say there will be a big mistake, can you think it? This is S, this is R, and this, let's say, let it be QN bar. Let it be QN. When S is 1, this has to be set. This terminal will definitely set. When S is 1, when S is equal to 1, this terminal will definitely set to be 1. This will become 0. Then contradictory. Though this is 1 and this is 0, they are opposite to each other, no problem. But you are saying QN bar. But in the truth table, we say, and S is 1, S is set. When S is equal to 1, QN is also should be 1. Now your QN is equal to 0. Then it is wrong. So terminal you cannot change. Can you understand?
Yes, sir.
Can you understand? Shall we try? It will take time. That is why I can try it. I can try it. I can prove it. Do you want proof?
No.
Shall I do it? Shall I do it? Okay, I'll do it.
Okay, sir.
I'll do it. You have to understand. So this circuit is a little bit big. I will go here. Okay. I can go in here also, there also. It's not a big issue. But since this is very simple, NOR base, let us do it here. But you have to remember the truth table. Truth table, please remember. As a student, you have to remember. You have to remember the truth table. Without remembering truth table, nothing is possible. You cannot be a master in this subject without knowing the truth table. This dotted line is just, this is the box, and this is the SR flip-flop or SR latch. That is the indication. Dotted line, don't worry about the dotted line. Now let me explain what if you change this one. Now let us see. I will change to Q bar. I will change to Q. Now, see, what does it say? When S is 1, see, the truth table say, when S is 1, R is 0, then the output Qn plus 1, okay, the next step, whatever, Qn will be set, it will be set, it will be 1. Now, so let us take when S is 1, okay, S is 1, R is 0, okay, then output, according to, I have changed it, okay, don't look over here, don't look over here, I have changed it. So according to this should always equal to 1. Is it okay? Is it the meaning, is the meaning okay to you?
Yes, sir.
Yeah, when S is set, R is 0, output, I have changed output, so Q, this is Q, or Qn plus 1, whatever, Q is also to be 1. Because I sometimes Q, the previous will become next, it is same terminal will become next, previous, next, previous, that's why whichever many you want to write, you write either Q or Qn plus 1 or Qn, and you can explain by yourself. So this should become 0. This is what, as a student, you are thinking, this is what, as a teacher, I am thinking, and you want to verify it. Now, let us say previously is, shall I put 0 or 1? 0 likhung. Okay, previously 0 and 1. Randomly I'm taking. Previously 0 and 1. 0 is connected here, 1 is connected here. 1 and 0, 1 and 0 and 1 is OR get 1. Output is to be 0. Okay, output is 0. I will box over here. Output is 0. New output is 0. 0 and 1 is 1. Bubble output is 0. So new output is 0. 0. So 0, 0 may be the transient state. So let's see again whether it stuck to 0, 0 all the time. 0 will go here and this will become 0. 0 will go here and it becomes 0. 0 and 0 is 0 followed by bubble. So 1. So next step will be 1. Next step will be 1. 0 and 1 is 1 followed by bubble. So 0. It will be 0. Now forget about this. Forget about this. Now this 1 will go here. 1 will come here. 1. 0 will go here. 0 will go here. Okay, as it is. 0 and 0 is 0. Opposite is 1. So next also will be 1. 1 and 1 is 1. Opposite 0. So next also will be 0. So 0 goes here. 0. 1 goes here. 1. Same thing will appear. So it will be always 1. It will be always 0. But the truth table says my Qn should be 1. My Qn should be 1. But instead you are getting 0. Because you change the terminal name. Can you understand?
Yes, sir.
So don't change the terminal name. You will, this silly mistake will make you a blender mistake, a big mistake. Even when I was in the master degree, I had been told by the teacher, why I remember, I have been told by the teacher to draw this using NaN. Then RS, I put RS, same thing, R on the top, S over here, without knowing anything. So that was the mistake. So teachers wants to know whether I know it or not. I do not know. So I simply follow it. So you should know the importance of all these things. So your mistakes will make you learn a lot of things. We learn from our mistake. So I still remember that this should not be like that. If it is R, then this should be Q. If it is S, it should be Q. Q is on the top always. Then sometimes you have to put S here, S. Sometimes you have to put R based on your logic gates. If it is NOR, you have to put R on the top. If it is NaN, you have to put S on the top, SR. That mistake, okay, that type of thing, you should always remember and don't make mistake at the time of drawing your circuit diagram. Your circuit diagram will carry a lot of marks. If the circuit diagram is wrong in the exam, I can give you to straight away 0. You can go for reevaluation. You can go to the court. You can check I want to check my answer paper. I will show you the answer paper. Everything is crystal clear. Everything is clear. You make a mistake, proof will be there. So be careful. I'm telling, I'm not threatening you, or I'm not saying that I will give 0, but circuit plays a very important role for engineers. The diagram plays a very important role. Okay, circuit diagram is very important. So let us see. This is the thing that we don't have time. So this I will tell you later on. I will show you the waveform. See, this is what we put up a waveform for clock SR flip-flop. See, clock SR flip-flop. It is there without clock. Let's see. Let's. How does a let's look like? Let's is without. I will simply draw the simple one with without this one. Simply this one. And NOR base because it is simple. So I should put R, then should be Q, and that's all. This will be Q and bar. Okay, this is the thing. We have two inputs, and this is a latch because we don't have clock. CLK clock is not there. So how does the waveform looks like? You will have a clear idea about over here. This is my output. Sometimes previous, next will go together. Okay, I will tell you. Now see where it is now. It is R is 0. S is also low. When R is 0, S is 0, let us think that Q is initially 1. Q is initially 1. See, Q, sometimes Qn plus 1, Qn plus 1, that's why they simply write Q. So previously, let's think that Q, my output Q, just Q, previously this is equal to 1. This is high. This is equal to 1. This is high. Previously, it is high. Oh, previously, it is high. Okay. Now, what is my R? R uncha ho gaya. R is on. This is a latch. It doesn't have a clock. So R is 1. R is 1. What about S? S is 0. R is 1. S is 0. R is 1. S is 0. What should be the output? According to truth table, R is 1. R is equal to 1. S is equal to 0. Output Qn plus 1 or whatever. The output is what? Set or reset?
0.
Reset. Reset. Correct. 0. Reset. So the output is reset. Correct. The output is reset. Then let's see here. R kya ho gaya? R becomes 0. R is 0. S also 0. When R is 0, S is 0, what will the output? According to table, R0, S0. क्या है? No change. No change था ना? अरे भाई याद करो ना. No change. It is no change. So the output will not change. So what was my previous output? It was low. पहले low था. Now it will also continue low. How long it will be low? जब तक R and S 0. R is 0. R is 0. R is 0. S is 0. S is 0. S is 0. Then output will be previous. Whatever previous will be next output. So it will be low, 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 low. Previous low, new also low. Previous low, new low. It will be low. Now, let's see. R is 0. S is 1. That means set. Output will become high. Output will become high. Yes, output will become high. Set ho gaya, output become high. From a truth table, we know. Now, let's see. R is 0. Again, S is 0. R0, S0, that means no change. What was my output? High. So, the no change, it will be high again. Okay, it will be high again. Till what time? Till R0. S is 0. Okay, it will be high. Previous, it will be high. Output will be the next, will be the previous. Now, R is 1. R becomes 1. That means reset. So now S is 0. That means it will reset. Reset ho gaya. Output will become low. As per the, can you understand? Are you following? So it will become low. It will become low.
Yes.
What happens? Suddenly R becomes 0. S also becomes 0. Then output should be no change. Output should be no change means what? Output was low. It will be low again. Till what? Till here. Yes, till here. What happens here? S is 1. When S is 1, R is 0. It will be set. S is 1 means set. The output will become set. And it will go here. Up to here, it will be set. So up to here, output will be 1 set. And then now, R is 0, S is 0. That means again, no change. So, uncha ho gaya. Q is 1. So, R is 0, S is 0. So, no change. That means the next output will also be previous output. Previous is 1, high. So, it will maintain high, 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 like that. So, this is for without clock. We cannot see any clock. So, this is for LATs, L-A-T-C-H LATs. And it is strictly written as RS LATs. And this is from another book. Anyway, this is good. Now, let us see what about the clock one. See, SR flip-flop with clock. And let us think that clock, what is this clock going to do? How to connect this clock? It's very simple, I told. It's very simple to connect the clock. Here, see, you're connecting the clock like this. You're connecting the clock like this. This diagram you should remember. Or you want to remember this diagram, You remember this diagram? Clock is connected like this, S, R. Just simply connect. And I have told if clock is high, then this is a NAND gate. The output will be the other output, S, then S bar like that. I have already told. So we have already discussed. So now, if it is clock, what to do? That is, this one will be easy. You are like easy again. Input and output from clock SR flow. Okay, this will be easy. Clock SR flow. Okay. See, this also. We'll do all the things. See, positive edge. See, clock. See, clock is going. This is positive edge, and so niche aaya, this is negative edge. So see, clock is like this. So you should know what is positive edge. What is this is positive edge. Positive edge. Positive going. Clock goes like this upwards. Positive edge, and downwards. This is negative edge. Negative edge. Negative edge. Positive edge, negative edge, edge. At this point only it will be triggered. At this point only it will be triggered. What is this? Positive level. Then what about this one? This is positive level. And what about this bottom one? This is negative level. Positive level, negative level. It will be like this. Positive level means what? From this point to this point, this many time it will be triggered. This many time it will be triggered. Edge trigger means what? At this point of time, small point of time it will be triggered. At this point of time it will be triggered. So edge trigger will have a great advantage. You will come to know. It will have a great advantage. That's why we take either positive edge or negative edge. In this case, we take positive edge trigger. Positive edge trigger means trigger at this point of time only. So you will see the difference between latch and the flip-flop, how the flip-flops works with the clock. So let's say this is my previously Q is 0, S is 0, R also 0, previously Q also 0, okay. Clock aa gaya, clock has come. At this point only we have to see. At this point, what is there? S is 0. At this point of time, what is R? R is 0. Then at that point of time, what should be Q? S is 0, R is 0, Q should be no change, correct?
Yes, sir.
Yes, sir.
No change. So Q 0, now also it will be 0. Yes, no change. Then input has changed, set ho gaya. S has set. Sometimes so many changes in the input, I don't bother. Input has changed, but the clock is saying, I don't bother. I have just opened my eyes, and what at that point of time, what is the value? Accordingly, it is 0. You should be 0 till I open my next eye. Till I open my eyes next. He opens his eyes next over here. That's why whatever value comes over here doesn't bother. That is why I say clock or SR flip-flop will have a clock, and the output depends on the input as well as the clock. There may be input available, but if the clock is not available, even though you are having input, you will not get any output. That is why it is slow. Whereas in case of latch, as soon as you have an input, turant you will get an output because you don't have a clock. But for flip-flop, there is something called clock. Input to aa gaya bhai, output abhi tak nahi aa raha, abhi tak nahi aa raha. That means clock is not ready. So device can be slow because clock has to wait. You have to wait for the clock to trigger. So now the clock has opened up. Another positive edge has come. At that point, what is there? Okay, S is 1. S is 1 at that point. Okay, R is 0. R is 0 at that point. Oh, S is 1. That means set. Or output will become set, high. Output will become set. Output will become high. It will become high unless and until another clock pulse comes. That means it doesn't bother about whatever changes has occurred in the input. I don't bother. The next pulse comes here, positive edge. At this time, what is S? S is 0, R is 1. That means R is 1 means S is 0 means reset. Output will now become reset. It will go down, reset, like that. So that is the difference between clock and without clock. When we see about without clock, see we were discussing about here, there is no clock. As whenever there is a change in the output, whenever there is a change in the input, whenever there is change in input, whenever there is change in input, every time the output keeps on reflecting the output. But in case of here, even though you have a change, lots of changes here, output remains the same. Even though you have a changes here, output remains the same. Can you understand the difference? Clock and without clock. Is it okay?
Yes, sir.
Yes, sir.
Yeah. Tell me. Up to this,
No,
we
no
will
doubt.
do. Yeah, up to this we'll do because it is getting late. Some people may be ready for the dinner. I'm really sorry for that. Please try to cooperate. I'm also tired from 9:30. From 9, even I didn't take lunch. I simply take some cup noodles and all. So 1 week I have to use with cup noodles. Okay, I don't have time to prepare my food also. I'm staying alone. So please bear with me. I know the difficulties this week. We'll do like this. So anything you want to ask?
No,
No.
sir.
Okay, you please try to understand this SR flip-flop and very thoroughly. Rest of the flip-flop it will be just very easy for you. And if you do not know this, you cannot be a good, you cannot perform good in the exam. Because in the exam, I'm not going to ask straightforward question. And I'm going to ask design. You have a D flip-flop, you design D into T flip-flop. You convert T flip-flop to SR flip-flop. So design is required. For that, you need to know thoroughly because those will be a problem only. Problem only I'll be asking. By this, I'm not trying to scare you. I will be doing the examples and then I will show you. You can ask any questions during the process. That means you should know thoroughly. Okay, not just by knowing these are the flip-flops, these are the truth tables. Just mugging up the truth tables and this thing will not work. You should know very thoroughly. Okay, that is the meaning of studying engineering, not simply mugging up. Okay, if you have any doubt, you can ask anytime. So with this, I will wind up because I have many things to discuss. I have lots of things I have, but I am not able to complete. I thought I will be able to complete anyway. No problem. Let us not worry about all these things. Understanding is very important. So you please put your attendance and you can log out if you don't have any questions. If you have any questions, you can ask anytime. No problem. I'm ready. I'm waiting. I'll wait for the question. If you have, you ask. If you want to log out, also you can log out. But put your attendance and log out. If anybody having questions, you are free to ask. And tomorrow also, please bear with me. Tomorrow also, just 1 hour, 5 to 6, I have to take every day. Tomorrow also I will take from 5 to 6. Now it's already 6:30. Tomorrow I'll take up to only 6 because lots of things we have to cover.